Hi everybody, welcome back. So if you'll notice, we have the exact same circuit, but I've added a couple of things. I've given it a frequency, meaning we're at an alternating source now. So we have alternating current, we have an AC circuit. I've added an inductor with an inductor reactance of 10 ohms. So now we're going to look and calculate what the total opposition. So now I can't, in the previous video you noticed I called it resistance total and said you might call it impedance. We can't call this resistance anymore because it has more than one component. It's not just resistive, it's resistive and inductive. So you'll see this is an RL circuit sometimes. So now when I'm calculating this, I left this up here very intentionally, okay? Because none of these fundamentals are going to change. When I go to calculate my impedance total, okay, those three values stay intact, perfectly exactly where they are. I didn't change that. What I would like you to think of quickly is what's going to happen though to my total impedance. If you understand what happens to opposition as I increase it, or as I add values in series, what's going to happen to my total opposition? Okay, if you said it's going to increase, you're absolutely correct. Because all I'm going to do is I'm going to add my XL value. But what you have to be very, very careful with is that you don't go 4 plus 4 plus 4 plus 10 just linear, because this is not a linear operation anymore. We are entering into a value that's displaced at an angle of 90 degrees between its components. So this is where I'm going to use the convention of a complex number, and I'm going to say I'm going to add it, the imaginary value of I to that at a value of 10 ohms. So I'm going to say 4 plus 4 plus 4 plus I of 10 ohms, okay, is going to give me 12 ohms plus I at 10 ohms. Now, if you were asked for the rectangular coordinates of this, you would leave that there. Okay, this is not an improper way to say the total impedance. 12 ohms plus I at 10 ohms. Okay, there's nothing wrong with that. That's a perfectly viable statement. You know you have 12 ohms in phase and 10 ohms out of phase. But quite often what we want to do is to come up with what that total value will actually be. Okay, so then to come up with that, just got to grab my calculator. I forgot to do this calculation ahead of time. And I get 15.62 ohms is my total impedance of this circuit. Okay, so you can see it's not 22 because they were not added directly together. There is a displacement between the resistive and the inductive component on this circuit. So that would be my final answer. If I wanted to know the total impedance as a singular magnitude, if I wanted to know the rectangular form, this is the rectangular form of that value. So I hope this helps. We'll look forward to seeing you in the next one.